If T of t is the temperature at time t, we might wonder if there is a specific time when the temperature is the same as the average temperature. For the temperature function graphed in figure 1, we see that there are two such times, just before noon and just before midnight. In general, is there a number c at which the value of the function f is exactly equal to the average value of the function? That is, does f of c equal the average of that function? Now the following theorem says that this is indeed the case for continuous functions. So the definition for the mean value theorem for integrals: if the function f is continuous on the interval from a to b, then there exists a number c in that interval such that f of c is going to equal to the average of that function, which is equal to the formula of the average function. And that is, we would say that the integral that goes from a to b of the function dx is equal to f of c times b minus a. Now, the mean value theorem for integrals is a consequence of the mean value theorem for derivatives and the fundamental theorem of calculus. And this proof is outlined in exercise 21. Now, the geometric interpretation of the mean value theorem for integrals is that for positive functions f, there is a number c such that the rectangle with base AB and the height f of c has the same area as the region under the graph of f from a to b. Now, if we look at figure 2, and you can see that there's more of an interpretation. So if you take a look here, you have this integral here. We go from a to b, right? It forms this rectangle, and then you have this height, which is f of c, which is equal to f, the average of that function. And you can see here that the height is the value that's in between a and b, which is c. So you can always chop off the top of a two-dimensional mountain of a certain height and use it to fill in the valleys so that the mountain becomes completely flat. So you can see here you're chopping this off, and there's that part there.